He is Richard Feynman, the Nobel Prize-winning physicist from the California Institute of Technology.
You asked me if an ordinary person, by studying hard, would get to be able to imagine these things like I imagine. Of course, I was an ordinary person who studied hard. We're exploring, we're trying to find out as much as we can about the world. People say to me, are you looking for the ultimate laws of physics? No, I'm not. I'm just looking to find out more about the world. And if it turns out there is a simple ultimate law that explains everything, so be it. That would be very nice to discover.
Perhaps even more importantly, he was an amazing teacher. He did a series of lectures which were for people who didn't specialize in physics. It's such a great example of how he could explain things in a fun and interesting way to anyone. And he was very funny.
Incidentally, at the time of Kepler, the problem of what drove the planets around the sun was answered by some people by saying that there were angels behind here beating their wings and pushing the planet along around orbit. As we'll see, that answer is not very far from the truth. The only difference is that the angels sit in a different direction and where wings go now.
Feynman was already well respected in the scientific community, but it was his investigation of Challenger that made him famous to the general public. He realized that NASA and its contractors tended to discourage their own employees from criticizing legitimate safety issues.
Oh, I took the stuff that I got out of your seal and I put it in ice water. And I discovered that when you put some pressure on it for a while and then undo it, it maintains, it doesn't stretch back, it stays the same dimension. In other words, for a few seconds at least, and more seconds than that, there's no resilience in this particular material when it's at a temperature of 32 degrees.